All right. Well, thank you everybody for joining me this morning for lesson number 6, Zoom Q&A. We're going to be taking a look at soils and soil maps. And yeah, thank you all for being here today. And congratulations on everybody who's submitted and got through lesson 5. It's a tricky exercise to go through, and yeah, it was really heartwarming to see everybody's assignments. There's a few I haven't got to. I think there's 3 or 4 I have not graded yet, so I'll be doing that probably a little later this week. I'm hoping to take actually this week as a pretty quiet work week. Got a lot of stuff to deal with at home here, so um, I'll definitely take a look at it and give everybody that I haven't marked some good feedback. Um, yeah, but it was impressive, and it's a huge part of the permaculture design process. So once we get through that water section, which we have, now we're going to be taking a look at soils, which, as you can imagine, are equally important. They're just, they come under the water layer in terms of the process, and certainly the process that I use with my wife and myself use with our work is the first thing that we look at is that water layer, and we design that water layer. And then once that is done, we actually do access next. So it's a little different than the course is set up, but but soil definitely comes after it. And it's easier to make changes or enhance soil rather than trying to make significant changes with water flows. So that's all part of the scale of permanence, the Oman scale of permanence, and it's something to check out if you've never heard or looked at that. But it's a list of different elements and their importance, not so much their importance in the landscape, but the degree of effort required to make changes to it. So if we take a look at water before we take a look at soil, as you can imagine, it'd be pretty hard to be making changes to water flows versus enhancing and improving soils. So without further ado, let's take a look at the assignment. I've put the question document in the chat here. If anybody has a question they want to fire in there during my little spiel here, I'm going to try and keep this to an hour today. So I think that's totally doable. One nice thing about the soil lesson, or lesson number 6, is it's significantly easier than lesson 5. So I think everybody will find it's a nice, gentle transition into the second half of the course here. So let me just share my screen. There we go. And that's our Q&A document. So here we go at lesson 6 assignment page. And there's a number of things. It's all about soil this lesson, as you know. And basically, we have a number of different steps that we want to take in this lesson. And the first is mapping the project site. And I believe everybody in the class here, or most, are within the United States. And you have a fantastic resource that I would encourage you to get familiar with, and that's the USDA soil website. And it's not very intuitive, so I'm going to walk through how we end up finding survey results with that. Just to give you a quick peek at that. The other thing we want to do is a jar test, a soil jar test, and that is pretty straightforward. We have some sample videos here. And it's a very simple, quick way of determining your sand, silt, clay contents. So that's your soil texture. And that can be really helpful in giving you a bit of a snapshot of the conditions that you're dealing with. And pretty much no matter what you have, whether it's pure sand or pure clay, you can change the behavior of the texture. You can't change the texture, but you can improve it. Um, Funny enough, through the use of organic matter and compost. So most of our solutions to both um, heavy soils and very light soils are the same, organic matter. And that's definitely our friend. Compaction can also be an issue, and we'll take a look at that, some of the ways we can deal with that. But this is pretty straightforward how we're going to do this percolation test. And some of you might find that at the end of your test, even though your soil texture may be quite free draining, that your site isn't. And we're going to look at why that might be and some of the ways that we can improve that. But this is a very good indicator of what you have in terms of what you're starting with, and that's an important place to be. The third part of our lesson here is just looking at the results of the jar test and comparing them to the map. So if you're in a rural area, they often match up well, and if you're in an urban area, they may not. Often urban landscapes are pretty sandy, so if at one time they were agricultural or that kind of land base, you'll see that they've shifted with development, or better known as destruction. That's the reality of what we do when we go and create a subdivision. But let us take a look at our soil mapping. So this is where a few people can get stuck, and I just thought I would run you through an example of how we get there. So I've got USD site, and there are, just to let you know, there are some pretty good instructions here um, to get you started. So I would definitely follow those. And this is the USDA site. So the first thing we want to do is just click that green button. And maybe what I'll do, I am going to take Frankie's address here. So this is an urban site. Let's go back here and we're going to start this process. So the first thing we have to do, oh, it's already shot me into my results. So we'll pretend we don't have that, and we're going to start again. First thing we have to do is define an area of interest. So to do that, we want to go down to the state. So I believe we're looking at Oregon. And we hit view. So boom, we've got the state of Oregon. And then we want to, this is what I do anyhow, go to that quick navigation above the state, and we can paste in our address and go view. And right in the middle of the screen is our site, our project site. So at this point, what you want to do to get the data from the database here is establish an area of interest. So that's this button up here. And it's pretty easy. You just click on that and we'll make a nice big square here. And we're going to define for the website what we want to look at. And it'll give us this sort of shaded polygon. And I believe the project site is right in here. So once we've done that, that's half the battle. At that point, we have our area of interest established, and all we have to do is click on the soil map tab that's next to it. And once we do that, it's going to access its database, and it's going to give us the results, which is this unit here, which is 51 A, and it gives us a little legend on this left-hand side. So it's urban, and it's it's not telling us a lot of information here, but if we click on that, we do get some interesting info that you can hit printable version. You can do a screenshot here, but this is what you want to include in your soil map portion of your assignment. And it basically tells us the soil texture during through various layers or profile layers of the soil. Okay, and then we're going to take that information and compare it with the jar test. So a couple screenshots in this section. And again, this is a good place to do so. I'll back out a little bit. So you want to take this screenshot and then this, or at least the information that you're getting out of this report. And really, that's all we have to worry about in this portion of the mapping. Now, with a rural site, it's going to be a little bit different, and we're going to get more or less this kind of information where we get different soil types as we go through the area of interest. And you'll see here, I'm trying to remember whose map this is. This is Mike's. I don't know if Mike's on the, nope, Mike's not here today. That's no big deal. It's a couple of acres, and I just need to, there we go. That's what it looks like from above. So it looks like we are right in this area here. And so Mike, it looks like Mike's pretty lucky. He's just got one soil type, which is the HGB. So if we click on that, we get a processing area, which is unusual. Now this may have to be reloaded. I'm not absolutely sure. See what we get there. Oh, I've got several maps open. I don't think it likes that. So why don't I close a couple of these? There we go. No, didn't like that either. Well, we'll start over. Okay. We'll try again. So the state, we're going to be looking at Washington. And I don't know if I copied that address. No, it doesn't want to do it on that page. I'll try that. There we go. All right. So again, we've found the location we want, and then we have to define our area of interest. And I always like to go outside of that just to see what other soil types there are, and then we're going to hit the map itself. There we go. So let's see if this works now. There we are. So here we go. We're getting that profile that we're after. And a bunch of other information as well. Depth of water table, the drainage class, that's all really good data. Now, where I live in British Columbia, Canada, we have an excellent map system. It's just quite different. So if you are outside the US, there are other ways of accessing that info. And it looks like we have a question here from Grace. So if you have, she's saying that there's 3 different soil types for her site. Should you use 3 different soil tests? That's, I believe in the assignment, we're asking for 3, at least we used to. Let me just take a look at the template file. Yeah, it's a good idea to do multiple tests in various areas, and sometimes there are areas you're going to put a new garden in, or here we go. Yeah, it looks like we're asking for 3. Yep. So that might be a good, it depends, Grace, though. If one of the soil types, I know you have a riparian area within your project. So if that was an area that had a different soil type, which is quite likely, and you're not planning to do anything except maybe remove invasives, I wouldn't worry too much about that. But I would focus on where you see expanding or enhancing your landscape. So maybe where you're going to put a new garden or where you have an existing one. That may be the way I would approach it. You don't necessarily have to work within those particular zones. And Sabrina's got a question here. How do you know which area the HGB, HDT is referring to? So if you look on the map itself, and let me just zoom in a bit. You will see the legend here. So here's HGB, here's HGD. So each band is going to have a different soil type. So that's basically how you differentiate those. Yeah, so this is an excellent resource, and you can go much deeper into this. And honestly, I don't use it because all my work's in Canada. And again, we have an excellent resource. It just is a completely different setup. But I would say that this is probably superior in a lot of ways because they actually went out and did a lot of this soil surveying years ago. I think it was the soil conservation, um, it was a soil conservation department within the government that did this. So I'm not sure about downloading soil data, whether you can do that. There you go. I haven't gone there, but the soil mapping again, if you click on this, you're going to get a lot more info. And you can explore this website. So there's a lot more to it, but just for this assignment, that's what we're after. What's the soil texture, the drainage, um, the various layers within the profile. Okay. Any other questions about the soil map? And again, if you have any challenges, there is a tutorial right here on it. And again, it's all about establishing that area of interest. That is the trick. Otherwise, if you just put your address in, it doesn't seem to function. It needs to have at least the state designated. Okay, so again, this is the kind of info we're after. That is provided on the site. So farmland classification, and then those profiles, the drainage, depth to bedrock, frequency of flooding, the water storage and profile. So really interesting information. And then we go to soil testing. Again, we have that jar test. So that's pretty easy. It's just using a mason jar. That's one of the easiest ways to do it. And typically, I'm not sure what the video says, but you could put, a third or a half of that would be your soil sample. And then you fill the rest with water and you agitate it, shake it up really well, and just put it somewhere where it's not going to get disturbed and it'll settle out. So the more sandy your soils are, the quicker it'll clear up. And if you're on really heavy soils, a lot of clay, then it might take, it could take a week for those clay particles to settle out. So when you're looking at your jar, I'm not sure if we have a good image here that we can. So you'll notice there'll be some very distinct, um, let me just see if I can find something here. There'll be some very distinct lines. There we go. Let's take a look at that. That's not great. It's actually quite hard to photograph. That one's not too bad. So you'll notice when you do your test, the heaviest material goes down to the bottom. So that's sand. And that, borders on sort of gravelly material. And then the next layer is much finer, and that is going to be silt. And then your very top layer, which of course is going to vary considerably with everybody's samples, that's your clay layer, and that takes quite a long time to settle out. And this is a pretty good image right here. So often, with many of the jar tests that I see, the clay layer is just ever so slight. And again, it takes a long time to settle out. This is quite silty, and then a fair amount of sand at the bottom. Now, this would be a lot easier to read if you have more within your jar. And as you can see, then trying to figure out the percentages is much easier than if it was something like that, right? So I would definitely recommend half full is a great idea. And then if some of you may notice that you have material floating, and that's organic matter. So that's a great thing to see. It's just not going to be part of the soil texture. This texture is the sand, silt, clay part of your soil. The organic matter is um, also a part of it, but it is something that is not, well, we'll call the parent material. And I think that's about it for I'd say the most challenging part is getting good images that are easy for others to read. So you may need to zoom in a bit. You may need some external lighting, but do what you can, and then labeling the photo like they have here. This is great. This is very, very helpful. And then it gives you your percentages, which then you can translate onto your soil texture triangle here. And that'll tell you where you're at. So where I live, we're a sandy loam. We've got quite a high percentage of sand and silt, and a very small amount of clay. So when we do a percolation test, like this here, where we dig a hole that's a foot wide and a foot deep and fill it full of water, it'll drain out in about 5 minutes. It's just unbelievable. So we know we need a lot of organic matter in order to retain water for as great a period as possible. And that water is also really going to help enhance our soil organisms and increase the population. Because, just with worms, because everybody can see them, worms need, about 70% moisture to mate, and they want about 50% ideally to live in. And that's quite a high level of moisture to maintain. And that's not necessarily going to be all the way up to the top of the surface. But, if you want more worms in your garden, you definitely need organic matter and you need moisture. So those two tend to go together. A good example is basically 1% increase of organic matter in your soils will hold 20,000 extra gallons of moisture over an acre. So if you have an acre, let's say you just had an acre of lawn, um, or pasture, if you're able to increase that by 1%, you have 20,000 gallons increased storage. So that is by far the easiest way to store water is in the soil. Um, and that's a big, that's one of those low-hanging fruits that is the easiest to do. Um, so that's just to keep in the back of your mind. There's the one thing that we don't really get into here with the soil test is the soil food web. And I took some training with Dr. Elaine Ingham, and it was really eye-opening, quite amazing. And she is responsible for discovering the soil food web. So prior to her work, let me get an image here. Prior to her work, um, science really believed soil was inert and it was dirt, right? Um, didn't have a lot of life. And certainly with modern agriculture, that can be the case because we disturb it so much. But when soils are left alone or in a no-till situation, you get this diverse, huge diversity below ground that feeds above ground organisms. So, worms are obviously part of this big picture, and there's different levels, and go down to microscopic. So it's quite amazing when you consider that a diverse, rich topsoil, 1 tablespoon of it can contain over, gosh, what is it? It's over 1 billion soil organisms. It's just, it's quite mind-blowing, because that's really getting into the micro, but they are responsible for cycling nutrients within our landscape. So without them, nothing's going to happen. If you put organic matter down and there's no soil organisms, nothing will happen. We need the organisms to convert all this material into elements that are soluble within and usable within plants. So it is a fascinating field, but it's again one part that we don't dive into, and you could spend, literally weeks, and this course does. And I'm not advocating the course, it's just one, it's another rabbit hole one can go down. And I've had a couple students that have gone on to become consultants, soil food web consultants. And for those who have larger properties or you want to learn more about this, one thing you can do is uh, have a soil test done by a certified soil food web lab. And there's a map here. You can go on. I know where I live uh, in British Columbia here. This is the lab I use in Vancouver. And They're fantastic. Joe Tobias. So it's a very easy process. You take a sample and you send it off, and they are testing for what is alive within the soil, not the texture. That you can easily discover yourself, but they will tell you what's alive in it. And based on what you're trying to grow, they'll give you recommendations on how to make improvements to that to put it into more alignment with the crops you're trying to grow. So we've used this before. Excuse me. We have Pollen City here today, um, alder and Douglas fir. So yeah, that's a little bit about soil. I hate to, there's no pun intended, but we're scratching the surface here with this assignment. And you could take a deep dive into this. And I was very fortunate that when I was, um, very young in my 20s, and I was an apprentice with the Vancouver Park System, and I was working with people that were definitely in alignment with building soil using organic matter. So it was just all part of the process that I learned, and it's become less that way with um, I guess with training in general. I know that there's a big push for fertilization and the use of pesticides and herbicides. So the challenge there is all of these salty, for instance, salt-based fertilizers have a negative impact on all of the life below the soil. So if you start depleting this because you're using a product that you're hoping to increase fertility, you're actually creating soils that are going to be more dependent on those synthetic fertilizers. So it's a slippery slope, and it's something I would highly recommend people avoid. Even, believe it or not, even organic fertilizers. So anything with salt in it. And that tends to be what happens with granular products. It is salt based. So I don't want to go on too much about that, but those are little bits that aren't part of this lesson, but I do feel they're important to carry with you beyond the course. Give you a bit more of a big picture. Wow. All right. Try and get my throat clear here. Um, let's see what else. Oh, yes. So then we're going to go and we're going to take a look at your soil samples, how they compare with the map. What are some of the limiting factors that you have identified? So you may find that you've got soils like we do where we live, a sandy loam that drain rapidly. So for me, a limiting factor would be trying to hold organic matter within the soil. I know this is something we do annually, and I'd say this year so far, we've brought in about 20 cubic yards of compost and probably need to get more in here just for our food production. And we have a new rain garden, to enhance some of the soils that we brought in for that. Um, Joe here has a question. Could you manipulate the soil composition only through biological and nutrient dense? Yeah, it's a two-step. My experience is it's multiple steps. So I won't say just two, but adding biology, because we've done that. We will we do our own composting for small batches where we live. And what we'll do is we'll take that and we'll extract it. I don't have a picture handy of what we've got here, but we have a compost tea brewer Let me see if I can find one that resembles what we have. Because that's another thing. There are brewers and brewers. Yeah, this is the kind of thing we have right here. Very similar. So what we do is we take high quality compost, we put it in a mesh bag that's specifically designed for compost tea extract. And then we fill the brewer with water and we turn it on, and it's basically an air pump that drives to the bottom of the unit and creates a vortex. And we put the bag in, and then after 20 or 30 minutes, this agitation will extract the biology out of the compost. So, 99, hopefully 99% of the biology is out of there and it's in the oxygenated water. So it's alive. We even find sometimes we'll have worms that are alive in the water as well. It's quite incredible, but it is oxygenated. So what we do is we take the bag out and we take that compost, put it back on the pile because there's nothing wrong with it. It just needs to be re-inoculated. And then we empty our extractor into watering cans and apply it onto the soil surface. Okay. Now, if you wanted to do foliar feeding, what you'd probably want to do is the first step, which I said, where you're extracting, and then you'd want to add some food and create a tea from that. So that is a much trickier operation because what you're having to do is add food for the biology, but just enough for populations to grow, but not overgrow. So what can happen is if you get overgrowth, even with that machine running, because that's what you end up having to do, keep the machine going for, it could be, 24 hours if you're doing tea. The tricky part is again, that population. And if it overgrows, you'll end up with some anaerobic conditions. So there will not be enough oxygen within that vessel to sustain all that growth, and you'll get a die-off and potentially some pathogens enjoying that low oxygen environment. So we tend to use compost extract because it's just so easy. The compost tea is much harder to do really well, but that's what you have to do if you're doing foliar feeding. And so you need a microscope and you need a little bit of knowledge of what you're looking at. And personally, I have a microscope and I've gone through the course and done all this stuff, but I absolutely hate using a microscope. I just don't like looking through it. Um, so I avoid it. um, I, I, I think the extract, we did that probably for about 3 years in a row as we're really trying to build our soils for our annual garden, our annual production for our food, because we grow 95% of our own veggies. So we did that about 3 years in a row. And now, all we seem to have to do is add organic matter. And we're in a no-till situation where we use a broad fork and we don't turn over the beds. That's probably one of the biggest mistakes that people can make is thinking they're improving their soil by turning over their beds. And what you're doing is you're just completely annihilating the habitat that you've been working so hard to develop. Um, and you can imagine if your world's turned upside down, you have some um, populations of soil organisms that survive, but you get a lot of dieback, and then it has to rebuild. So things like tilling, plowing, sometimes you have to do them at the onset of an area to prepare it. We avoid it like the plague, but what we do is we use a broad fork. And this is great for small areas. And this is the one we have. It's a friend who's a fabricator made me one that was exactly the same as the Meadow Creature, which I think is one of the best out there for this part of the world. Very strong. And we have kind of rocky soil, whereas these types would be great in a nice fluffy annual bed, but in the soils that I'm working with, I would bend these tines quite easily. So this is a beautiful tool, and that together with a penetrometer is something that we have in our toolkit. I'm trying to remember, I think it's called a Dickie John. Yeah. Let me see if we can find it. Oh, we'll just go for images here. There we go. This is great. Very simple. What it is basically a rod with a handle and a meter. And there's not a whole lot that can go wrong with this. Um, and you have two different tips you can put on the unit. Unfortunately, I lost one of them, but I didn't lose the one we always use, so I'm okay. But all you do is and we do this in our annual beds. We will basically uh, go to an area, push into the soil, and you can see on this meter here, there's a green, yellow, and red, but I have a kind of a revised way I read this with Dr. Elaine Ingham's course. Basically, once you get to 150 psi, it gets very difficult for plant roots to push through that. So I don't go with 200, I go with 150. And if I went out there today in our beds and pushed it in, it'd just float right through, right down to about 18 inches. And if we go back to this broad fork, that gives us about 14 inches of depth. So beyond that, I can't really do much in terms of decompaction. And, for most of our crops, I don't really want to worry about that. On a larger scale, what we do is we use a keyline plow. We're really lucky we have one on Vancouver Island where I live. And these are fabulous. They are a plow that is designed to break up. You can see the way the tine is developed. They break up below ground compaction, and they do not disturb the surface, minimal disturbance. Now, a lot of these there's all kinds of attachments. Often you'll see people with a roller. So when they cut, they can roll it, and it helps to get, say in this situation, it would speed up your timing to when you could put animals back on the pasture here. Some units have compost tea or compost extract applicators on the back that feed right at the base of the shank here. Others will have a seeding machine as well. I mean, there's no end to the modifications that I've seen on these. But again, you might find if you're on an acreage site and you've got compaction issues, which is completely normal, especially if equipment gets run on it and tractors, you'll find there's a zone that of about 3 inches that occurs below the tires, and this plow does a marvelous job of breaking it up. And it can also be used in conjunction with keyline design, where you're putting patterns on the landscape to distribute water from areas that have an abundance to areas that are drier. But again, we're not really getting into that. Otherwise, you'd all be here forever. But it is, it's a deep rabbit hole, keyline design and the use of plows. So these are fabulous. We've even used them on, gosh, we used them on a site that we designed. It was 10 acres. Client, it was almost old growth forest, very old forest. They took down and then they bulldozed the whole property. They had D9 cats on it, and we took our penetrometer out there, and it was, a quarter inch, boom, into 300 psi or greater. I couldn't get the unit in below a quarter inch, so we had a keyline plow go out there and rectified it. So pretty amazing tools that you can implement to help with compaction. So a couple things in the chat here, Joe. You've got a penetrometer, right on. Good for you. They are a fabulous tool. I would recommend everybody have, because they can tell you so much. We take them to all of our design sites, and it's shocking actually in most urban areas. Most of the sites are compacted, and people are struggling to grow what they want. And just by alleviating that compaction, it's a whole new world. Because if we look at the soil profile, believe it or not, the top 8 inches of your soil has an air exchange once an hour, right? So it's just amazing to think about that. And hence, having a rich, biodiverse community of soil organisms with that oxygen exchange. So when compaction becomes an issue, you're basically removing any possibility of those organisms thriving. And then you start leaning into organisms that will do well with low oxygen. And they tend to be the pathogens we don't want. Right on. So let's go back and just make sure we've covered everything here. Yeah, we have that narrative, and we're going to talk about some of the compost elements that you might have. So we're looking for, this is a very simple way of looking at composting is we have green and brown materials. If you want to make thermophilic compost, which is hot, we'll call that hot compost. It is tricky, and it is more of a process where we're looking at nitrogen and carbon. We have to have a certain amount of nitrogen in order to get heat generated. And we want to minimize the disturbance of that as well. So we end up turning a pile, say 2 or 3 times, but there's many ways of doing it. I'm trying to think. There's a 21-day compost, Berkeley, I think it's called. And I believe Jeff Lawton's got some videos on that. It's an 18-day, so 18 or 21. And, that's great. And that can generate some compost quite quickly. It wouldn't be usable right away, but it gets the bulk of the activity going. Now, the downside of this is because it's heavily disturbed, you end up with you lean heavily towards bacterial organisms. So that's the advantage of this no-till approach is you encourage both bacterial and fungal dominated organisms. And you want to, ideally have both and in a good balance. So the hot composting that you're turning quite a bit, or you'll see composting tumblers. Yes, you're going to have a product that looks nice, but the population of the organisms is going to lean heavily in the bacterial side of things just because they can survive that sort of disturbance, whereas fungal tend to have quite delicate structures, and those end up getting damaged when you turn the pile. So if we look at thermophilic composting, oops, there's a lot of videos that you could access, and I'm sure Dr. Elaine Ingham's got a few. She has, yeah, there you go. That's worth looking at. Her system uses a wire cage rather than a compost bin, because you want to increase oxygen flow, especially when your pile gets hot, because it needs a lot of oxygen in order to stay away from that anaerobic layer. And some of the commercial composts you buy can have that. This is a fabulous way of for commercial compost. It's like a windrow and a compost turner, and they can even inject water when they're doing this. There's a lot of really good equipment out there, but not often used for commercial purposes. So again, you buy commercial product, it's probably been handled a lot, and it'll be low in fungal organisms. But it's the reality of the situation and reality of the work we do. We don't have the ability to create enough compost for ourselves, let alone for clients. So we tend to create small batches of high quality compost that we use in our potting mix for our greenhouse and for compost extract. So Joe's got another question here. Do you recommend the use of JADM or KNF anaerobic practices? Yeah. Well, personally, I haven't really dove down those rabbit holes. I was heavily influenced by Dr. Elaine Ingham's work, and if you went through her, she has a number of courses now. When I took it, there was less variation in her courses, but the reality of what I learned is that if you want to have a really sound product, it needs to be aerobic. And that is what, we're trying to achieve when we make compost. And that's what we would be trying to do when we create a foliar application, because it has to stick as well. That's a whole other ball game, is applying the foliar spray so you don't destroy the organisms when they impact the foliage, as well, so that they stick rather than running off. It is tricky. Now, there are a few, I'm trying to remember some of the products that are eluding me right now. I think what you might find is that these anaerobic products have a fairly narrow bandwidth of organisms in them, whereas, say, a high quality compost, you're trying to extrapolate this really broad spectrum. That's not to say, what you have mentioned here wouldn't be effective. I'm not saying that at all. I just don't have a lot of personal experience with it because I've been influenced going in that other direction. So I think foliar sprays are really effective, but you do have to make compost tea in order for those to stick properly. And I don't find where I live, I just don't have to do that. We don't see the problems that warrant that on our property, our little homestead. And certainly the landscapes we're involved with, we start with really high quality compost right out of the gate. And, we just don't see pests and disease problems. And I think that's part of it. When you start seeing problems in the landscape, that's usually or often can be soil. You could trace it back to soil. And, whether that's compaction, whether that's a lack of organic matter. Um, yeah, so hopefully that helps out, Joe. I'm sorry I can't really dive into that. I'm trying to, gosh, it's escaped me. A product that I think you're alluding to there that is an anaerobic process. But again, it's a fairly narrow band of organisms that you get from it. So not to say it wouldn't be good. Um, Again, it's just what I'm used to. So, all right. Let me see if there's any questions. No, there's no questions on the Google document here. So does anybody have any questions today they'd like me to address? We've got a few minutes left, and then I've got to try and escape as close to 10 here as possible, but I certainly want to answer everybody's questions. There you go. Gabriel's got a message there for Joe. Yeah, and that is another thing, with cannabis being um, allowed in terms of growing commercially, that there has been a lot of work with the soil food web involved with that, because again, you're getting into a situation where you're trying to, um, especially when you try and grow plants in a greenhouse, it gets really tricky. In pots, in soilless mediums, um, that's where soil biology can be a very interesting addition. So it's a huge rabbit hole, and there are lots of resources out there. So if you're interested in that, I'd certainly encourage you to go down that rabbit hole. Um, and you might not come out. It's that's one reason I was initially thinking of becoming a soil food web consultant, but I um I like to do a lot of different things, and with that, I think you end up getting quite focused. And I didn't feel like I wanted to just dial in on that. I love design. I love the education end of it. So yeah. Anyhow, does anybody have any other questions or comments for today? We're all good. And if you find as you're going through this week, putting your assignment together, if you find you have any, don't hesitate to drop me a note. I'm happy to answer those. You can put them in the help discussion board. I keep my eye on that. I'm trying to have a bit of a light week with work this week, but I'm definitely checking in on the courses. We have a new course starting today, so I have to check in and greet people anyhow. Yes, the assignment is due next Monday. Let me just double check, but that is my understanding. Yeah, it's due on the 10th. So we've got a whole week. And yeah, I hope everybody had a nice little break. Uh-oh. Sorry about that. That was bound to happen. Um, Yeah, so we're all good, and thank you again for joining me today and with the excellent questions. I look forward to seeing everybody's assignment and giving you some feedback on that. So have a great week, everyone, and we'll check in with you all next Monday. Take care.